All right, so this will be starting with the first question, and it's obviously, as usual, it's from units and dimension, right? From units and dimension. So let's focus on the first two questions. Right. First one is from units and dimension. The other one is from measuring instruments, and they have given us what? They have given us the units of certain quantities. If velocity is v, force is f, time is t, in alpha equal f over v squared sine beta t, what are the dimensions of alpha over beta? So in here, this is the main equation we have to focus on, right? This is the main equation we have to focus on. And people, in that, first tell me, we know that when you have, now, hold on a second. The equation is alpha equals f over v squared sine beta t. If that's the case, we can first say whose dimension is who is dimensionless. Whoever is inside sine it's dimensionless. So dimensions of bt equal to 1, which means dimensions of beta is equal to 1 over dimensions of time, that is 1 over capital T. So that is t minus 1. That's the first step. And then who else is dimensionless? Someone else is dimensionless. Who is that? The whole sine beta t part is dimensionless. Why is that? All the trigonometric functions, just like cos, sine, tan, they are dimensionless. For that reason, we can say dimensions of alpha should be equal to dimensions of f over v squared. So dimensions of alpha will be f force. Force is ml t minus 2. What is v squared then? L squared t minus 2. L squared t minus 2. Then, who will get cancelled off here, people? I think we can get rid of t minus 2, right? T minus 2 will be gone, which means, hold on. T minus 2 will be gone, which means the final answer. Oh no. Alpha's dimensions is going to be ml minus 1. ml minus 1. Right. So the final answer. We are supposed to find out the dimensions of alpha over beta, dimensions of alpha ml minus 1, dimensions of beta t minus 1. T goes up, so final answer ml minus 1 t. Hence, second one. Okay. Second one is the answer for the first. Can I move on to the next one? Number 2. Right. So we have done hundreds of questions like this about spherometer, but this question had a problem. But you should have figured it out. I'm not going to give you all marks, all for this. Right? Let's see why. Circular scale of spherometer consists of 50 divisions. If main scale moves 1 millimeter distance during 2 complete turns of a circular scale, what is the reading in shown instance? Right. Right. So let's see how we can handle this question. Right. So in here, first and foremost, we have to check where the circular disk is. You can see the circular disk is below main scale 0. And it just passed who? 1, 2, 3. It has just passed 3. So when you find the reading is equal to what now? 3 plus something. Yeah. No. I didn't get you. What? Oh, yeah. Okay. Right. So my point is the reading has to be 3 plus. Reading has to be 3 plus because the disk is below 3, which means we have to eliminate some answers. That's how you do MCQs. So you are sure that 4th can't be the answer, 2nd can't be the answer, 3rd can't be the answer. See the probability now, 50%. It's either 1 or 5. Good, right? And then people, the problem starts. Then I think we need to figure out something here. Now, what is it? Least count. Least count. Before that, we have to find out the pitch. It's 1 millimeter over 2. What is it? 0.5 millimeter. But we don't have to really waste our time finding the least count. But never mind. Okay. And then we need to find out the least count. What is least count, people? Least count is equal to 1 circular scale division divided by no. 1 main scale division. Oh, sorry, pitch. Pitch divided by number of circular scale divisions. What is the answer then? Half a millimeter divided by 50. So pitch is 0.01 millimeter. Most 99% of the time, this is the least count for a spherometer. But I have seen questions where they give 0.005 also. So better to find it. But in A level, I don't think they'll go that far. Okay, right. So we have the least count. Now we need to figure out the coinciding unit. Which unit is coinciding here, people? It is this one, no? This unit. And what is that? It's 23. 23. 23. Why not 23? Here 25, 24, 23. It's 23. But can I directly take 23? No, I can't directly take 23. Why? The circular scale is below main scale 0. So you don't take 23 directly. How should you take it? 50 minus 23. That is how you should be taking it. And you multiply that by 0.01 millimeter. So the final answer is 3.27 millimeter. That answer is not there. But first can't be the answer for sure. Why is that? Because in the first answer, they have taken 23 directly. So in the end, what happens here is actually 3 is there, 4 is there, in between 3.5 is there. They have not shown that. So we have to understand that the circular disc is below 3.5, not 3. You have 3, you have 4, because it has to turn twice not to go down. It has to turn twice for 1 millimeter. When it turns once, it has gone half a millimeter. When it turns next time on, it will go the next half millimeter. So what I'm trying to say is it's between 3 and 4, but since 3.27 is not there, we have to assume that it is below 3.5. Since this first one can't be the answer for sure, why can't it be the answer for sure? You don't take 23 directly. So out of the remaining answers, what is the most suitable answer? Fifth one. Now you might argue, sir, why not 3.27? It should be the answer now. No. 3.5 is missing here. Okay, so if I put it this way, wait. How this scale will look is if you magnify and draw this point, if you magnify it and draw, wait, I'll show it. If you magnify that and draw, this is how the disc is, people. This is how the disc is situated. 3, this is 3, this is 4. That's all we see. They have not given who? 3.5, they have not given. 3.5, they have not given. Our disc is here. Does it make sense? Our disc is here. This is where the disc is. So instead of 3, we have to put what? 3.5. If they had given 3.27, we can consider that answer. But so 50 is the answer. If you put 1, no, it's definitely wrong because the disc is below 0. So 50. All right, next question is about laser lights. We haven't still covered that in the syllabus, but for the sake of completing the question, we'll quickly have a discussion about it. But I think some of these questions you can answer about laser light based on your knowledge on light. All right, next question is about laser light. Now, consider the following statements regarding laser beam. How many of you know about laser beam? You all know about laser beam, right? Laser, like in those toy guns and all you have in movies and all, the sniper and all they use. So I'll quickly explain about the difference between normal light and laser light. Normal light, it will scatter and go everywhere. Now, when I turn on a light, the whole room lights up. If you take a laser beam, it just creates a spot on the wall. Now, when I turn on a laser light, it doesn't light up the entire room because all the laser light waves, they have the same frequency, they have the same wavelength, they go in the same plane. So they create a beam, but the normal light is not like that. Number 2, laser light is, tell me a unique feature of laser light. Laser light is monochromatic. It has one color. It can be red, it can be green, it can be blue. But the normal light is a mix of 7 colors. So laser light has several different colors. So if you go to first statement, statement A, laser beams can be generated in different frequencies. Do you agree with that? Yes. Different colors, different frequencies. So A has to be what? Correct. So to answer that question, you don't have to learn laser specifically. So if A is correct, people, which answers cannot be correct? First, second, fourth. So it's either 3 and 5. And we have a bonus here. In 3 and 5, C is correct. Which means we don't have to worry about C. we have to worry only about B. But unfortunately, B you will know only if you have learned the process of laser. I'll just give you a small idea about laser. What we do is, in laser, you have learned chemistry, right? In chemistry, what happens in according to Niels Bohr's theorem, when you provide energy to electrons, what do? They go for high energy levels. They go for high energy levels and then they come back to low energy. When they come back to low energy levels, what do? They emit energy in the form of electromagnetic waves. That's how laser is produced. So the pumping machine is needed to pump energy, to pump the electrons to high energy levels. And this resonator is needed to amplify the energy. So they accelerate the electrons and make the laser beam stronger. The laser beam is stronger than normal light. For that purpose only, we will be needing the resonator. So for that reason, obviously, for this question, what is the correct answer? All three are correct. Okay, all three are correct. When we learn about laser, we'll discuss about that in detail. You need to know about laser light in detail because these days A-level MCQs will be discussed. Now, I did not explain anything here. I should have drawn diagrams. There is the ground state. There is the excited state, metastable state. Likewise, there will be cases. We'll learn about that separately. Right. So I'll leave it there. Let's move on to the next one. Diagram shows the variation of force versus time. So force with time acting on an object of mass 5 kg. The velocity of the object when time is equal to 0 is +1 meters per second. What is its speed during 7 seconds? Okay, right. So whenever they have given us a force time graph, what should be our approach? Force versus time graph, we have to find the area. Yeah. So the equation, and they have given a very important point is this. Yeah, there is an initial velocity. Yeah. Velocity of the object when time is equal to 0 is +1 means who is 1? U is 1. U is 1 meters per second. Okay. So according to whenever you see force time graph, you need to go to Newton's second law. Ft equal to mv minus mu. Whenever they have given you an Ft graph, how will you find Ft, people? Yeah, area of force time graph. Area of Ft graph. Right. Now, what is the area of the force time graph here? You have to be a little careful. You will have to separate this into how many steps? I think 2, no? There is a triangle here. There's a triangle I've highlighted in pink color. And who else is there? There's a trapezium, but you have to be extra careful. They are talking about 7 seconds. So you have to take area only until this point, right? So 2 shapes, triangle and trapezium. Shall we find the area of the trapezium first? What is the area of a trapezium? Area half into addition of parallel sides. What are the parallel sides below? Okay, will you? 3 plus 1. Agreed? 3 plus 1 into this length. How much is that? This is 7. This is 3. So 4, right? 4. When you multiply this, what do you get then? 8. And what is the area of the triangle? Half into base into height. That is the area of the triangle. So that is going to be 9 by 2, 4.5. Now, 4.5, what is the unit? Newton second. Okay, 8 Newton second. Done. Then for F into T, what will I substitute? 4.5 plus 8. Mass 5. Final velocity we have to find out. Minus mass 5 again. What is initial velocity? 1. We normally put 0 in other questions. 12.5 equal to 5v minus 5. So 5v is equal to 17.5. What is b? B is equal to 17.5 divided by 5. 3.5 ms minus. Answer 3. These are like bonus questions. You can't make mistakes. Right. Question number 5. Diagram shows the variation of displacement versus time graph drawn for the displacement measured from the moment when two vehicles AB moving in a straight path pass a particular point P. Consider the following statements. Acceleration of B is higher than that of A. What do you think of that, people? It is 0. It's an ST graph, displacement time graph. And what is the meaning of this part of the graph? Will you wait? What is the meaning of this part of the graph? It's constant velocity. Constant velocity, positive. What is the meaning of this part of the graph? Rest. So I've written the definition for A in blue color. And what about the second vehicle, B? This part, it is also constant velocity in positive direction. What about this one? Constant velocity in negative direction. Therefore, definitely the first statement is wrong. Why? Because acceleration for both the objects continuously is what? 0. Constant velocity or rest, it's 0. If A is wrong, first one is wrong, third one is wrong, fifth one is wrong. But the problem is in the scheme, they have given the third answer as the correct answer. We'll have to change that. Yeah? It's not the third one. It can't be the third. But in Tamil medium, I think it's different. What have they told? They have asked for the incorrect one in Tamil medium. Ooh. If they ask you for the incorrect one, A and C are incorrect. Right. Wait. No, wait, we'll discuss. At time t equal to t3, where here, A and B meet together for the second time. Do you agree with that? Why not? Okay, tell me, when are they meeting? At what time are they meeting? Huh? Okay, in a displacement time graph, when will two objects meet? When? Wrong. No. When the graphs meet. When the graphs meet. When their displacements are equal, they will meet. Okay. So, as usual, now we don't have to do this, but for your understanding, I will quickly explain this part. Shall we try to interpret the graph? Try to interpret the graph. What we are going to do is we are going to try to figure out where they are at each time. The problem is now the time here time is 0. This time I'll take it as t naught. All right. So I was saying yes. So they both are at the same place when time is equal to A is here, B is also here. Understood? A is here, B is also here. When time is equal to 0, A is starting its journey. When time is equal to t naught, B is starting its journey. I hope you can understand. Why do I say that they both at the same point? Because their initial displacement is 0. And then look at this point. They are meeting here. They're meeting here. I'll take the displacement as S1, which means when time is equal to T1, they both are again at the same place. And what is the displacement? S1, which means from the starting point, they both have moved S1 distance, but B started later. That's the difference. A started when time is equal to 0, B is waiting. See, B is waiting, and it started a little later, but it's moving at a higher speed, so it quickly catches up with it. Right. And then what is happening? B is overtaking A, and A is going behind, and again they are meeting. When is that? At this point, when time is equal to T3. When time is equal to T3, they are meeting once again. A and B. People, when time is equal to T4, where are they? Yeah, no, not they. Only one person will come back to the initial one. But I'll mark B here. This is B in blue color. B in blue color. B in blue color. Right. When they meet, right, wait. When they meet for the first time, both are going where? To the right side. Do you agree with me? Because constant velocity, positive direction. Where both are going to the right side. When they meet for the second time, where are they going? How are they going? A is still going, A is moving. No, A is at rest. A is at rest. Velocity of A is 0, people. Look at the graph. The A rest in a graph. But B, what is it doing? It is moving in the opposite direction like this. Okay, right. So B is correct. B statement is correct. Because you have the proof here. We have the proof here. Is C correct? C is false because their velocities are not opposite. A is rest. Velocity of A is 0. Velocity of B is not 0. So it's not opposite. So in Tamil medium, should be the answer. For English medium students, it should be the second. If they're asking for the true state. All right. Okay, right. So now, if you take this question, 6.1 is about thermal physics, and I'll quickly go through that. Diagram shows a composite bar made using 4 different metal pieces taking S shape when heated up to 90 degrees Celsius. So this is not how it is when it is under normal room conditions. Their coefficients of linear expansion are mentioned. So for you to get an idea about linear expansion, alpha is called the linear expansion. If a material has higher alpha, it will expand more. If a material has lower alpha, it will expand less. Simple as that. Okay, right. So what we need to understand here is this. The diagram they have given is at what temperature? 90 degrees. But our room is not at 90 degrees, people. So they have heated it to 90 degrees. Initially, it was at some temperature. Tell me a temperature. Maybe what, like 30 degrees Celsius or something like that. They are saying it was in the shape of I. It was in this shape. It was like this. Understood? It was like this. And then due to the temperature increment only, it turned to that shape. Turned to that shape. So this is what you call a dimetallic strip. And this is like alpha 1. This is like alpha 2. This is RT now. What is RT? Room temperature. This is 90 degrees Celsius. This is a very simple question, people. Very simple question. And here we have another material and another, this thing. Right. Okay. So this is alpha 4. This is alpha 3. This is alpha 1. This is alpha 2. They all have equal lengths. Just common sense. Compare between these two metals and tell me which one has expanded more, alpha 1 or alpha 2. Alpha 1, it has bent more, right? So we're looking at that now. This is when you heat it. When you heat it, this happens. So obviously, from according to this diagram, I can say alpha 1 is bigger than alpha 2. You should go from initial to final. And between alpha 3 and alpha 4, people, alpha 4 has expanded more than alpha 3. That's all. Is there an answer to that? Which one? Okay, but it's not fair for me to expect you to have answered this question, but it's very simple, right? But it will not be always as simple as this. Yeah. So, right. Next question. Right. How many of you tried this question? 7th one. It is maybe the simplest question in this paper. Yeah. It's scary. It looks very scary, but it's very simple, people. Why? Two prisms of refractive indices N1 and N2 are kept in contact as shown in the diagram. N1 and N2 are in relations with the wavelength lambda. Listen, have you studied an equation like that? No. No, don't worry. They have given you an equation. If the value of lambda for a light ray incident angle to pass without refracting on BC, if you want a light ray to do this, what is the condition? See, now it is it's going like this. See, no, wait, not perpendicular. They are not specifically said that it's perpendicular. They have said for any angle, it should not refract. This is alpha. This is alpha. Yeah, very good. What is it? For this to happen, N1 has to be equal to N2. Why? If this is glass and this is also glass, will refraction happen? No. That's all. Right? So see, if the value of lambda for the light ray incident angle to pass without refracting, okay, light ray incident to pass without refracting. So for that, the condition is N1 should be equal to N2. We have learned, people, if N1 is bigger than N2, it will refract away from normal. If N1 is smaller than N2, it will refract towards normal. But if they're equal, no refraction, no deviation, right? What you need to do is, I will try to build the argument this way. Wait. When no refraction happens, no refraction takes place, what's the condition? They have said lambda is equal to who? Lambda naught. Did you see that? Here. The value of lambda when light ray does not refract is lambda naught. The lambda is equal to lambda naught. And what is the other condition? N1 and N2 both should be equal. So how do you incorporate both these into an equation? That is this. N1 is equal to N2, na people? Yes, but N1 will become equal to N2 only when lambda is equal to who? Lambda naught. So if N1 is equal to N2, I can write 1.2 plus 10.8 into 10 to the power 4. Instead of lambda, what should I substitute? Lambda naught squared equal to, what is it, N2? 1.45 plus 1.8 into 10 to the power 4 divided by, again for lambda, what should I substitute? Lambda naught squared. Simple as that. Right. So what will happen now? Shall we take the numbers to one side? I can take 1.2 to the other side, this to this side, right? So what will I get? You know, lambda naught squared is a common denominator. On top, 10.8 into 10 to the power 4 minus 1.8 into 10 to the power 4. All right. On the right side, what will be there? 1.45 minus 1.20. Okay, up on the left side, what is left out? I'll continue it here since I'm running out of space. Here, people, I'm getting 9 into 10 to the power 4 divided by what? Lambda naught squared. On the right side, please. 0.25. What is 0.25? 25 over 100. So, but finally, I'm getting lambda naught squared is equal to, if I take this up, 100 will go up. So 9 into 10 to the power 6 divided by 25. So what is lambda naught? Oh, no. I think I made a mistake. Wait. Something is wrong. Wait. 10 to the power 4. Did I make any mistake here? No, right? How will we get nanometer then, people? The power 4. Huh? Don't know whether lambda is already nanometers, is it? Yeah, it must be like that. No? Then when you take square root, what are we getting? 3 into 10 to the power 3 over 5. So yeah. So what am I getting for lambda naught? 3005 is 600. So lambda is given in nanometers already. Therefore, answer should be 5th. Anybody who got 5th? Nice. It's not as difficult as it seems. Very simple. No, not very simple. For thinking, you take more time. For execution. Okay, since I've missed to record this explanation, I will quickly explain this again. This is how the beaker will be at the beginning with water. And when you just put the vessel inside, the water will rise because to create the upthrust of the vessel. Now the vessel is floating. Okay, vessel is floating here under the weight of the vessel, and the upthrust on it will be acting. Then when you attach another object at the bottom, that is the metal piece, the weight, or you are increasing the total weight. Therefore, the total upthrust of the system also should increase if the system has to float. Therefore, the vessel rather has to submerge more, so that water level on either side will have to increase. Water level on either side will have to increase more, right? So that's what I've explained here. Therefore, they are saying in statement A, they are saying it will not change, but statement C, they're explaining this, why the water level goes up on either side. Okay, right. So, sorry, and then the metal piece falls down. The metal piece falls down. what happens is the total weight reduces. Earlier, the total weight was the weight of the vessel plus the weight of the metal piece. The metal piece falls down. Now we have only the vessel to be balanced, vessel's weight to be balanced. So upthrust will reduce a little. Therefore, the vessel will float more. So the water level on either side will fall. That is explained in statement C. Okay. And last statement B, when you put the metal piece inside the vessel now, the total weight is still the same. When you compare diagram A and diagram B, you can see the total weight is still the same. What is the total weight? The weight of the metal piece and the weight of the vessel. Weight of the metal piece and the weight of the vessel. But in statement A or diagram A rather, metal piece is also surrounded by water. So it is giving its submerged volume is contributing to upthrust. Its submerged volume is also contributing to upthrust. Therefore, only a smaller portion of the vessel has to submerge to create the required upthrust. But in the last diagram, diagram B, since the metal piece is inside the vessel, only the vessel has to create the submerged volume to make the system float again. Therefore, it has to sink more compared to situation B. Then only it will be able to create sufficient upthrust, balance the two forces. I'll repeat. The weight in both these instances is same, but the upthrust is also same. So upthrust should be equal. But here, upthrust is created by both the vessel as well as the metal piece. But here it is created only by the vessel. Therefore, vessel has to sink more in the last situation. And that's why B is correct, because when the vessel sinks more, the water level on either side in beaker will go up. That's why B is correct. All right, question number 9. Figure shows a pump. Okay, there was a problem in the question. In the question, they are saying points PQR, but they have given ABC. So I think students should have the common sense of figuring out that A is P, B is Q, and C is R, right? In the Tamil medium paper, it was given as ABC in the answer as well, but I think what we have to assume that Q is B, the middle point, R is C, the corner point, and the initial point is P. We'll take it that way and continue. Figure shows a pump filled with liquid of density rho. What do you call this object? What do you call this object? I can't remember the Tamil word. We call it a siphon. Call it a siphon. When was this used specially? Few years back. When people want to take out petrol from their tanks, so they use this. What they do is, yeah. And a boy, do you know, a boy tried to take petrol out and he drank or inhaled petrol and he actually died. Okay, so don't do that. Figure shows a pump filled with liquid of density rho. Respective heights are noted. Assume that the atmospheric pressure is P0. Consider the following statements. Right. First, without reading the statements, let's analyze the function of a siphon. The purpose of the siphon is to take out liquid through a tube. Now, wait, you must be wondering, right, why do we need this? We could have directly poured the liquid from the beaker. Imagine this to be a petrol tank or something like that. So this part will be closed, right? Closed. So then you can't take it out. You need stuff like this. But anyways, let's follow the question. What is the principle behind this question? What is the principle behind this question? It's Bernoulli's principle. They have given height, they have given density, they have given pressure, right? And whenever you want to apply a Bernoulli's principle, what do you need? A streamline. Very good. You need a streamline. So you need to figure out a streamline. When you use a streamline, you should choose 2 points of which the pressures are known. Obviously, one of the point is who? R. Why is that? Okay, what is the pressure there? P0. It is exposed to air. Then I will choose a point here, which is also exposed to air, P0. And I'm going to take that point as PQR. We'll take it as XR. I'll take it as X. So the streamline I'm going to choose for this question is, people, this stream goes like this. If you have done past paper, then this should be bread and butter. But it's okay. Right, fine. What is the velocity here at point X? We can assume that it is almost 0. Because when you use a siphon, normally this tube will be a very small tube. Therefore, in the vessel, we can assume for that moment, the velocity is 0. What's the velocity here? Will it have a velocity here? Yes, it should have a velocity here. The point is, water should come out, or petrol should come out. If not, the siphon is not going to work. So For siphon to work, who should not be 0? B should not be 0. If B is 0, water is not going not going out. That's the point. So B should not be 0, right? Okay. Consider the following statements. So let's apply Bernoulli's theorem. How will you apply Bernoulli's theorem? For which points? And whenever you apply Bernoulli's theorem, you have to define a level. What level is that? 0 potential level. At 0 potential level, who is 0, people? Gravitational potential energy is 0. Right. Okay. So tell me Bernoulli's theorem for which points? Bernoulli's theorem for points X and R. Why not any other points? Because we do not know the in-between pressures, but we definitely know the pressure at X and pressure at R. Okay, so what is the Bernoulli's equation? I will write the whole thing. I don't want to do it, but never mind. Px plus half rho Px squared plus rho g Hx. People, you can write down with me, no? Without waiting. What is the pressure at R? Pr plus half rho Vr squared plus rho g hr. Right. What is the pressure at X, people? P naught. What is the velocity at X? 0. And what is the height to point X? Careful. How much is that? H3. Rho g H3 from the 0 potential level equal to PR P naught, atmospheric pressure. Plus, what is the velocity at point R? There is a velocity, half rho V squared. What about rho g HR? 0. That is a 0 potential level. Height is 0. Okay. So which letters can be cancelled out here? Sorry. Rho will get subtracted. Density will get divided. So finally, we will arrive at an equation for V squared. What is it? 2G H3. Therefore, what is V? V is equal to root of 2G H3. For siphon to work, what is the condition? For what to work? Pump, okay, pump to function. For pump to function, what's the condition, guys? Function V should be greater than 0. So who else should be greater than 0? H3 should be greater than 0 because 2G are constants. So H3 can't be 0, should be bigger than 0. Therefore, statement 1 is correct or wrong? Correct. If statement 1 is correct, which answers are wrong? Tell me quickly. Second is wrong. Fifth is wrong. We have 1, 3, 4. Pressure at point Q. In your diagram, it was point B. What is the pressure at point Q? Someone tell me. PQ plus H3 rho G is equal to who? P naught. Do you agree with me or not? Yeah, right? Normal pressure equation. So what is PQ, people? PQ is equal to P naught minus H3 rho G. Is the second statement correct? Yes, it is. So if B is correct, which answers are first can't be the answer. Flow speed of liquid at point R is this. Is it correct? No. Why? Because here we have figured it. V is equal to root of 2G H3, not this. Therefore, what is the correct answer for this question, people? Third one, right? It is not the exact past paper question. That's why I like about this question. Just the idea is past paper, but approach is different. All right, question number 12. An object of mass 10 kg moves along the curved smooth path AB from A at rest, and then moves along a horizontal rough path BD. So the path BD, the whole path is rough. Understand? Coefficient of dynamic friction between the object and the flow is 0.1. Where? From where to where? From B to D. Mu is 0.1. Okay, right. Is 0.1. It collides and joins and moves with the spring of spring constant 2 into 10 to the power 4 Newton meter minus 1 at point C and rests momentarily. So it's getting compressed and it's stopping. The maximum compression that could occur in the spring, neglecting the energy loss during collision, right? So I will have to draw another diagram. Should I really draw another diagram? Yeah, I might have to. No, I'll just draw the spring, people. So after some time, what will happen? The spring would have compressed a little bit more compared to its initial position, and our object will be here. And this is the length. Let's assume that this is the length the spring got compressed. Where I'll mark that in a different color. This distance is x. All right, fine. What is the initial velocity of the object? 0. Initial velocity of the object is, I'll put u is equal to 0. Right? And then people, the object will slide down. No friction here. Did you read the question properly? Smooth. Object comes here at B. At B, it will have a speed. But I'm telling you, we don't have to bother about that speed. You don't have to find that speed. Because at A, what energy does it have? Only gravitational potential energy is there. Who is 0? Kinetic energy is 0. At B, who is 0? Gravitational potential energy is 0. Kinetic energy is there. So whatever the gravitational potential energy you have at A, you are going to have the same kinetic energy at B. Whatever the energy you have here in total, we'll have at B. And when you go from B to this final point, all the energies disappear. It had kinetic energy here. When it comes here, it has nothing. Why? It is losing energy in two ways. One is because of friction. Second one, it's converted to elastic potential energy. Okay, so I'll write an equation, see if it makes sense. I'll take this point as point x, final point. I'll write an equation, see if it makes sense. Gravitational potential energy at A is equal to kinetic energy at B. The total kinetic energy of B is equal to what? Work done against friction plus elastic potential energy at x. Okay. At this point, it has potential energy. All that potential energy will be converted to kinetic energy. And all this kinetic energy, when the object comes to point x, is converted to what? Work done against friction. And the elastic potential energy stored in who? The spring. Indirect, I can say, what can I say? Gravitational potential energy at A is equal to what? Work done due to friction plus elastic potential energy at x. Sorry. People, the delta WF is work done due to friction. Huh? What is the gravitational potential energy at A? Shall we go with the equations with mgh equal to dynamic frictional force into the distance travel plus, for this one, what should I put? Half kx square. What is the gravitational potential energy, people? Mass 10, g 10, height 10. What is the frictional force? We know dynamic friction is equal to mu d r. So mu d is how much? 0.1. R is equal to mg. What is m? Sorry, 10. What is g? 10. What is ft? 10. So yeah. So 10 into what should I put for the distance? Tell you. No, 10 plus x. Because it's moving a distance of x also. Don't forget that. Plus half k and 2 into 10 to the power 4 into x square. Now this is where your mathematical instincts should kick in. If you leave this x like this, it will be a big headache. Now I can sense that some of you have forgotten about x. X it's not okay. Right. X should be taken into account, but you can ignore that. Can someone tell me the reason for that? Because look at the answers for x. 0.1, 0.2, 0.3. Compared to 10, those values are very small. 10 and 0.1. Tell me, Leo. 10 is 100 times larger than 0.1. So 10 plus x is almost equal to what? 10. So we can ignore x. So within bracket, I'll put this. 10 plus x is almost equal to 10. Why? Because x is very small. All right, then. I think after that, it's not that challenging. Shall we finish it off quickly? Yeah, who can be cancelled out, people? The 2 and 2 will get divided. Then who else can be? Okay, I'll continue to expand it. This is 1000 on the left side. This is 100 here. Plus, what is this, guys? 10,000 x square, isn't it? Now I can get rid of who? Couple of zeros from everything. No? Can get rid of this, you can get rid of this, you can get rid of this, which means 100x squared is equal to 9. What is x squared? 9 over 100. What is x? 3 over 10. Answer 0.3 meter. Very good. You should consider x in some questions. What if this distance was just 1 meter? Then you have to take x. So yeah, but it's not a crime for not taking x. Your answer x எடுத்து செஞ்சா செய்யலும் என்ன வரும்? You will get a very weird quadratic equation. இதெல்லாம் அம்மா வாழ்க்கை எடுத்துரும். Simplify that. The answer for this question is how many of you got that? 0.3. Yeah, good job. Question number 13. Two stationary sound sources S1 and S2 generate sound waves of frequency 165 Hertz. So for both the initial, the original frequency is 165 Hertz. They're also 165 Hertz. Okay. Figure shows a car moving towards S1 at speed 20 meters per second. So 20 meters per second is what? The speed of the observer. Speed of the observer. What is the beat frequency heard by the observer in the car if the speed of sound in air is 330 meters per second? So C is 330 meters per second. Why will there be a beat frequency? Because the car is hearing two sounds. One sound coming from S1, two sound coming from S2. So the observer in the car will be hearing two frequencies. One is F1 frequency of sound from S1 and F2. All right. So what is beat frequency? Let's write F1 first of all. What is F1? Equation for F1. Observer moving towards the source. Avadani Mudai Nokia said. So what is the equation? C plus VO over C into F0. So F1 is equal to C 330 plus V0 enough. 20 divided by 330 whole thing multiplied by 165. When you see 165, it's good news. Why? 165 is double, 330 is double 160. So it's going to be 350 by 2, isn't it? Answer 175 Hertz. Similarly, people, what is F2? If F2 just a small change, what is it? C minus VO over C into F0. Why is that? Because for S2, the observer is going away from the source. So F2 will be equal to 330 minus 20 divided by 330 multiplied by 165. Again, 330 and 165, 2. So that is how much? 310 over 2. What is 310 over 2, people? 155 Hertz. Finished. What is beat frequency? Beat frequency is the difference between the two frequencies. F1 minus F2. 175 minus 150. 25 Hertz. They could have asked. 155. Sorry, 155. So it's 20. 20 Hertz. Hence the answer is second. How many you got second? Very good. Right. Okay. Question number 14 is about strings, stretch strings. A stretch string is vibrating at its fundamental frequency. If it is made to vibrate at fundamental vibration after increasing its tension by 69% and reducing its length by 35%, what is the ratio between the final and initial fundamental frequencies? Right. This should not be difficult. First of all, now situation 1, situation 2. In situation 1, let's take the fundamental frequency to be equal to F1. Situation 2, let's take it as F2. In situation 1, let's take the tension equal to tension equal to T. Then in situation 2, people, what is the tension? Tell me. Tension increasing its tension by 69%. So it has to be 169 T over 100. not for the time being, let's put it as 1.69 t. And length, if I take the initial length as L, what should be the final length? Yeah, we'll ask Najima. They are talking about length here. Yeah, reducing its length by 35%. Don't stand up. Just so what should be the final length? 35% reduce means 69% increase means you add that to 100. 35% reduce means you should be 100 minus 35 t over 100. So what is that? 0.65 t. That's it. All right, done. We have the comparison made, and then what is the equation for fundamental frequency? F naught is equal to 1 over 2L root of T over M. Who are the constants? Mass per unit length will not change if you don't change the string. And yeah, M is constant, that's all. 2 is constant. Therefore, F naught is proportional to root of T over L. L is not inside the root. Careful. But what is F1 proportional to? Root of T over L itself. F2 proportional to root of 1.69 T divided by 0.65 L. Equation 1, equation 2. Let's divide the second equation by first equation. What will I get on the left side? F2 over F1. And what will I be getting on the right side? Root of T and root of T will get divided. L and L will get divided. So I'll be getting root of 1.69 divided by 0.6. What is root of 1.69? 1. Should be 1.3. This is where you have to be very careful. When I say root of 1.69, it is actually root of 169 over 100. What is root of 169? 13. What is root of 100? 10. So what is the final answer? 1.3, not 0.1. Got to be double careful. We had the same discussion a few months back about taking root for decimal places. 1.3 divided by 0.65. Up and down, if you multiply by 100, you'll be getting 130 over 65. What is 130 over 65? 2 over 1. Hence, the answer is